All right, now let's finish this lesson up with the minimum sample size formula. The minimum sample size needed when finding a confidence interval for the mean is given by this formula, where n is the sample size and e is the maximum error. So if we're using maximum error, we're dealing with the z, or the normal distribution here. So this will tell us how many samples we need to have, the minimum number of samples to give us a true number here. So it says this. Medical equipment manufacturer requires that its measurement tools error, I know it looks weird, but that's error, no more than plus or minus 0.01 milliliter with 99% confidence. If our standard deviation is 0.05 of a millimeter, how many measurements are needed? So let's write out our value. Here's what we know. The A value is going to equal 100% minus the 99% confidence, which is 1%, or we could say A is 0.01. And we want it to error. We want the error to be no more than 0.01 plus or minus, but I'm just going to put it that way. And also we have this standard deviation of 0.05. Okay, so what I'm going to do is I'm going to come over here to my calculator and plug in these values. The first is the alpha is 0.01. Okay, we have that in there. Great. We don't know the mean, so I'll just delete that. The standard deviation is 0.05. We don't know how many samples we have, so I can delete that. When I come over here, I need to also input my error needs to be 0.01. When I type that in, this tells me right here the minimum sample. What it does is it takes the z value, again for the 99th percentile, what the z value would be. It multiplies it by the standard deviation, it divides it by that error, and then squares the whole value. Our answer here is that we have a minimum. We need at least 100, and I'm going to say 66 samples. So truthfully, we'll usually be rounding that to a whole number, because if it's a sample size, usually we count wholes. I don't know many samples that you could have, like 3.5 samples, but for the most part, that's a whole number. And so I'll say at least 166 samples. And so the math in there, if you're wondering, wait, what just happened for the math, is to find that minimum, which the variable they use is n for samples. What you do is you take your z value, you multiply it by the standard deviation, and you divide it by the error, which they gave us, that's a z there, they gave us two of those values. What they did not give us that would be squared and squared. What they did not give us is the z value, and that's the quantile function. That's what I was talking about up here, or it's the normal distribution's quantile function. And so that's basically what happens right in here. And it calculates that value for us. Now, this one's not showing us the number. That's because I programmed that one specifically based off of having samples. But notice how this is a different letter here. It's not ZCI, it's just the Z. And so it's being calculated down in here. There it is right there. It's getting calculated, and the Z value on this particular problem for 99% confidence would be 2.575829, so on, so on. So that's the math that takes place right there to get that 166. All right, with that, you have a problem. Pause the video if you need more time, see what you come up with.